All right, in this video, I'm going to go over the review questions for our last unit test. All right, so you'll see in number 1 and number 2 that it's asking us to find the missing pieces or parts of these different non-right triangles. And like I've been talking about for a few weeks now, if I can use the law of sines, I'm going to try to use the law of sines. If I can't use the law of sines, that's when I use the law of cosines. So I use the law of cosines as like a last resort. So my first thought when I look at this first triangle, RST, is I notice I have two angles. So if I have two angles, I can actually find the third angle, right, angle R, which is going to be 180 degrees minus the sum of the other two. All right, and if you need to use your calculator, please feel free to use a calculator. I'll be using it, obviously, as we get to more into this problem. But we have 28 degrees plus 25 degrees, so that's going to be 53 degrees. And then if you subtract 180 minus 53, you're going to get what's that going to be, 127? I think that should be right. Yep, that looks good. All right, so angle R is 127. So that's one of the pieces that we're trying to find. Now you'll notice they already gave us this side length S, which is 10 yards. I don't know side length R, and I don't know side length T. So I'll be using the law of sines to find both of those. So I'm going to start with the sine of, let's do the sine of 25 degrees over T, all right? Because we have the sine of T, which is 25 degrees, equals, and another pair that I have, which is the sine of 28 degrees over S, which is 10 yards. Okay, so if I get cross products here, I have T times the sine of 28 degrees equals 10 times the sine of 25 degrees. Divide both sides by that sine of 28 degrees, and you get T equals 10 times the sine of 25 degrees over the sine of 28 degrees. So this will give us our measure of side length T. So I'm going to go ahead and bring in Desmos here. Make sure you're in degrees, so always click the wrench. So we're in degrees. All right, let's get our fraction. So our fraction is 10 times the sine of 25 degrees. So 10 times the sine of 25 degrees over the sine of 28 degrees. Just confirm. Yep. So our answer, if we're going to round, you can round to the nearest tenth, whatever you want, whole numbers, I don't care. 9.0 essentially is my yards here. So 9.0 yards. All right, so let's do the same thing. All right, we just found T, which is 9.0 yards. We're going to try to find R. So I've got the sine of R, which is 127 over R, equals the sine. And guys, I'm just going to use the same pair that I used on the previous one, the 28 degrees over 10. You'll see when I do number 2, it's a little harder to avoid. But if I can avoid using anything that's rounded, I'm going to avoid using any rounded values. So do a cross products. So R times the sine of 28 degrees equals 10 times the sine of 127 degrees. Divide both sides by that sine of 28 degrees again. So you get this for the numerator over the sine of 28 degrees. All right, so go back to Desmos to type this in. So I'll get 10 times the sine of 127. Let me just confirm. Okay, that looks good. Round to the nearest tenth is 17.0 yards. All right, so there's all three of my things. I've got angle R is 127 degrees, side length T is 9 yards, and side length R is 17 yards. Okay, so you'll notice in number 1, I only used the law of sines. Let's go to number 2. All right, now number 2, first thing I notice is I don't have two angles, so I'm not able to use my understanding that the sum of the angles in a triangle will add up to 180. So I have to then think, okay, can I use the law of sines? If you're going to use the law of sines, you have to have a pair, What I mean by that is you must have the angle and its corresponding side length. So I have angle D, but do I know side length D? The answer is no. So that means I'm not going to be able to use the law of sines, at least to start in this problem. I can use the law of sines. Once I get one of these values, I should be able to use the law of sines because then I'll have a pair. All right, so I'm going to use the law of cosines, all right, to find side length D, which is going to be D squared equals E squared plus F squared minus 2EF times the cosine of angle D. So I've got trying to find D squared, and E squared is 20, plus F squared is 30 squared, minus 2 times 20 times 30 times the cosine of 59 degrees. Now, again, when I type this in, I know I'm not showing my work here, but when I type this in, don't forget to do the square root of all of that. Because if you don't do the square root, then you'll just get D squared, and we want letter D. So I want to do SQRT first, and then type in all this stuff. 20 squared, 30 squared, minus 2 times 20 times 30 times the cosine of, was it 59? Yes, times the cosine of 59. And then I did the square root of that, so 26.1 is going to be my answer for D, 26.1. All right, and then that's rounded. Okay, so this is 26.1 units. Now, at this point, you've got options. You have all three side lengths, so you can use the other version of the law of cosines to find one of those angles if you want. You also can use the law of sines now. The only thing I'll caution you is if you're going to use the law of sines, is make sure when you do the law of sines, you do not use or solve for the largest angle. All right, so what I mean by that is if you look at these side lengths, you can see F is the largest one. So you never want to solve for the largest one because you could end up getting the wrong answer. So what you want to do is you can solve for angle E, right? Angle E is not going to be the largest angle because it's not across from the longest side. So you'll notice I avoid solving for angle F until the end because that's going to be my largest angle. If you want to deal with this in terms of like not having to deal with this, you can just use the law of cosines. Use the other version of the law of cosines to find either angle E or F. It won't matter. But if you're going to use the law of sines, which I am going to right now, make sure you solve for not the largest angle. All right, so I have the sine of 59 degrees. Here's my pair over 26.1. I know it is rounded, and I'm going to show you in my calculator how to kind of avoid the rounding until the end. Equals, again, I'm avoiding angle F, right? Angle F is going to be my largest angle, so I'm not going to use that one. So I'm going to do sine of E over 20. Okay, so again, I'm avoiding that largest angle, leaving it till the end. Do the cross products. 26.1 times the sine of E equals 20 times the sine of 59 degrees. Now, watch what I'm going to kind of combine two steps here. I am going to move over the 26.1 with division. So I can do my fraction here, 20 times the sine of 59 degrees over 26.1, but you notice I don't want the sine of E, I want angle E, so I do the sine to the negative first power of this fraction. That will actually give me my angle E. So I'm going to type this in. You'll notice I'm going to use the non-rounded version, so this right here is going to be my denominator. So sine to the negative first power of, and in the numerator, I have 20 times the sine of 59 degrees over, and my denominator is this value here, 26.1, which I'm going to paste in there. Again, it's not perfect, right? That still technically is rounded, but it's much better than doing 26.1. I'm not worried about on the test, guys. If you use the rounded value, I'm going to still give you credit. So no worries. I'm going to round to the nearest degree and get 41 degrees. So this is 41 degrees. Right? So if E is 41 degrees, that leaves me with finding angle F by doing 180 minus the sum of these other two angles. All right, so that's going to be 180 minus, let's see, 59 minus, or plus 41. That's going to be 100 degrees. and if you subtract that, you get 80 degrees. All right, and that shouldn't really surprise you because the longest side is side length F, and that should correspond to the largest angle. All right, so that's it for this one. Again, there are other options here. You could have used the law of cosines to find either angle E or angle F. Remember, if you use the law of cosines to find an angle, you don't need to worry about if you're finding the largest one or not. I use the law of sines, and I waited until the end to find my angle F. So I left my largest angle until the end to do it this way. All right, let's move to the backside. All right, the backside. We're going to graph some polar coordinates and then do some conversion of polar coordinates and rectangular coordinates. So the way you want to do this, remember, this is 0, this is pi over 2, pi, 3 pi over 2. And again, this one would be pi over 6, and this next one is pi over 3. All right, so I'm going to plot this first one, A. It does say negative pi over 6 for my angle, right? The form here is r comma theta. So my theta is negative, which means I'll be moving in a clockwise direction of 5 pi over 6. So 1, 2, 3, 4, 5. So this one here would be negative 5 pi over 6. I guess I'll label it. Okay. And if I'm moving 3 units out, go from the center, 1, 2, 3. There is point A. Let's do point B. All right, point B is 5 pi over 3, which the way I always think of this is like halfway around would be 3 pi over 3. So then here is 4 pi over 3. And so this one right here is 5 pi over 3. And I'm moving negative for my r, so I'm not going to count towards 5 pi over 3. Actually, I'm going to count away from it, 2 units, right, on the same line away from it to be letter B. And finally, letter C is a quadrantal, right? I'm at pi over 2, moving 4 units towards that. 1, 2, 3, 4. So this is point C. All right, so just make sure you're ready to plot some polar coordinates. All right, so my next two, 6 and 7, is the conversions that we're going to do where I go from polar coordinates, so these are in the form r comma theta, into rectangular form of x and y. So the two formulas you have memorized is x equals r times the cosine of theta, and y equals r times the sine of theta. All right, so hopefully you've got those memorized. So this is going to be 3 times the cosine of 7 pi over 4. Now what I do is I just do a quick sketch, right? 7 pi over 4 is actually going to be in the last quadrant, the fourth quadrant, right? You're starting here, going all the way around to 7 pi over 4. So finding the reference angle, right? Finding that reference angle is the distance from my terminal side to the nearest x-axis. And again, hopefully you're good. The reference angle is just the 1 pi over that denominator. So using your chart that you've had memorized hopefully for months now, I'm going to write down first the cosine of pi over 4 and leave room, because it could be a negative, is the square root of 2 over 2. But I'm in the fourth quadrant, right? So all students take classes, and C for classes stands for cosine. So because this says cosine, this is going to be a positive. So my x-coordinate is going to be 3 times the square root of 2 over 2. Let's do the same thing for y. So I got 3 times the sine of 7 pi over 4. So now I'm going to do the sine of pi over 4, which is, again, that square root of 2 over 2. But I'm doing all students take classes. Sine is actually going to be negative in that quadrant. So the answer for this one is going to be negative 3 times the square root of 2 over 2. So my ordered pair in terms of x and y, or rectangular coordinates, that matches this is positive, 3 times the square root of 2 over 2, and then comma, negative 3 times the square root of 2 over 2. I hope this doesn't confuse you, but it just take like 30 seconds and think, essentially if I were to plot this as a polar coordinate, and you know what, actually, I got it right up there. If I were to plot this, and I'll use a different color, I'll use pink. If I were to plot this point on this polar coordinate up here, 7 pi over 4 would be right in the middle, right? And if I went 1, 2, 3 units, right, you can see that this ordered pair, right, is going to be a positive x-axis and a negative, positive x value and a negative y value, which makes sense, right? I got a positive x value and a negative y value. So I always kind of do that to check, just to make sure, like, hey, does this make sense for my answer? Okay, let's do this next one. Doing the same work, right? Same work. X equals r times the cosine of theta. Y equals r times the sine of theta. So plug in what we know. R is -1 times the cosine of 7 pi over 6. All right, so let's sketch 7 pi over 6 over here. 7 pi over 6 is going to be in, let me use a different color so it doesn't get confusing, at least orange. Is going to be in the third quadrant. Right, it goes just past that value of pi, which would be 6 pi over 6, and the reference angle is going to be that distance back. So the reference angle, should not surprise you, is pi over 6. So really I'm doing the cosine of pi over 6. So from my table, right, the cosine of pi over 6 is the square root of 3 over 2. Right? I leave space in case it's going to be a negative or a positive. So we're in the third quadrant. All students take t for tangent. So actually this is going to be negative. Right? So when I multiply a negative times a negative, I get a positive square root of 3 over 2. And then this one here, all right, is going to be -1 times the sine of pi over 6. 7 pi over 6. And if I do that same thing, do the sine of pi over 6, the sine of pi over 6 is 1/2. All right? And, I should have left space. I said that, I didn't leave space. We're in the third quadrant. For tangent, this is not tangent, so it should be negative. So y is equal to a positive 1/2. So here is my ordered pair with x and y. And again, you don't have to do this on the test, but just want to show you. I'll go in orange to kind of help your brain understand like what we're doing here. If I were to have plotted this point on this polar coordinate at 7 pi over 6, 7 pi over 6 is actually on this line again, right? This is positive 7 pi over 6. But because it has a negative for the r, I'd be moving in the opposite direction. So this would be that point there. And you notice that's in the first quadrant where x is positive and y is positive. So it confirms, right, both x and y end up being positive. Again, you don't have to do that, but just trying to show you how these are related. All right, the last two. So going the other way. Now we're given the rectangular coordinates, and we want to plot them in or find them in polar form. So again, I always just do a quick little sketch. Right, this is 0, -3. I'll use purple for this one. 0, -3 is going to be down here. So you can probably actually find this if you want without showing all of your work. But I'm going to show you all the work. The formula we use to find r is going to be x squared plus y squared equals r squared. So you've got 0 squared plus -3 squared equals r squared. All right, 0 plus 9 is 9. All right, so if you take the square root, you get 3. Okay? Now, from there, to find our theta, we always do the tangent of theta is equal to y over x. So in this case, the tangent of theta is -3 over 0. Now, this should be hopefully a giveaway that something interesting is going on, right? Even if you didn't sketch it. This would probably kind of tell you, hey, you should probably sketch this. All right, this is undefined. Anything divided by 0 is going to be undefined. So this is what you should hopefully have already seen, but now this maybe will lead you to believe it. This is telling me that this is a quadrantal. All right, and if you look at my purple point here, my purple point in terms of the quadrantal, that theta is going to be 3 pi over 2, right? Because that's down in that negative part of the y-axis. So if I write my answer in the form of r theta, I'm going to write 3 comma 3 pi over 2. All right, so that's it for number 8. Let's do one more and then we'll be done. Same process here. I'm going to start with finding my r value using the Pythagorean theorem. Oh, I'm sorry. Let me sketch first. It's always important to sketch. So I'll use, running out of colors, light blue maybe? Is this strong enough? We'll see. So negative square root of 2, right? So negative square root of 2 and positive square root of 2 puts me at this point here, okay? So if I make my triangle, right, I'm trying to find theta and my r value. So to find my r value, I'm going to plug in negative square root of 2 squared plus positive square root of 2 squared equals r squared. Remember, squaring a square root means they'll go away. Negative squared is going to be a positive. So it's going to be positive 2 plus positive 2 equals r squared. That's 4 equals r squared, so r is positive 2. Okay, let's find theta. The tangent of theta is y over x. So tangent of theta is equal to the square root of 2 over negative square root of 2, which is actually a negative 1. Now, what I do and what I taught you guys to do is to find the reference angle first, which is tangent to the negative first power of a positive 1. So ignore that negative. And if you go to your chart, right, this is not a quadrantal because it's tangent with a value of 1. That reference angle would be in radians, pi over 4. Now, this could be my theta, but it could not be, right? I always go back to two ways to do this. You can look and see where tangent is negative, but really the thing that I would recommend doing is you've already sketched where this point is, right? Here is the point, and you'll notice that's in the second quadrant. So to find theta, I need to do pi, right? This is pi, minus my reference angle to give me my theta. So that's 4 pi over 4 minus 1 pi over 4 to give a theta of 3 pi over 4. All right, so here is my ordered pair with r, comma, theta. All right, and that's it, guys. So this is what you'll be expected to do on the test. Make sure you come see me in office hours. If you have any questions, good luck.